Okay, today I'm going to help you review how to solve systems of equations. We have three different methods. We can graph them, we can use substitution, or we can use elimination. Starting off, we are going to be using the graphing method. It'll help us review what the point is of a solution to a system of equations. Okay, right now we're looking at linear equations, and essentially the solution is going to be any x, y values, coordinate points, if we're talking about an x and a y, that satisfy both equations. So if I plug them into the first equation, it will come out that what's on the left does equal 6 on the right, and if I plug it into the second equation, it will also come out true. Okay, graphically speaking, we are going to be looking for any points then, x, y coordinate points, that satisfy or are on each line, because we are looking at two lines here. Now, to make it look a little bit better, let's take each line and let's put it into a more typical form that we see when we're graphing, and that would be slope-intercept form. So I'm going to take my 2x minus y equals 6, and I'm simply going to solve for y and put it into slope-intercept form. So I'm going to have a negative y equals a negative 2x plus 6, because I subtracted 2x from both sides, and I'm going to divide by a negative 1. Notice I'm dividing all three terms by the negative to give me y equals positive 2x minus 6 when I do 6 divided by negative 1. Okay, let's go ahead and graph that on our coordinate graph over here. So again, just a quick review. It's been a little while since you've done this. I'm starting with my negative 6 is my y-intercept. 6. It looks like we're down there. Maybe I should do that in a different color so you can see it. And now I'm going to go, my slope is my m. If you're remembering from algebra, y equals, whoops, mx plus b. That's why I'm saying m, and slope-intercept was b. So to walk my slope, I'm going to go, since it's a positive, 2, and there's nothing underneath it, I'm going to say there's 1 underneath it. I'm going to go up 2 over 1, giving me a point right here. Of course, we can do it again, up 2 over 1, and we're getting a line that looks something like this. Of course, I'm doing a little bit of freehand here, so not 100% the most accurate method, but we'll talk about that in a minute. Let's go ahead and graph our second line. So again, I need to solve this for y. I've got 12x plus 4y equals negative 4. I'm going to subtract the 12x to get 4y equals negative 12x minus 4. And divide by 4. All three terms, giving me y equals negative 12 divided by 4 is a negative 3x, negative 4 divided by 4, minus 1. Okay, starting with my y-intercept of negative 1 right here. My slope of negative 3, again, that's over 1, if you want to think of it that way. So I'm going down 3 this time, right 1. Or you could think of it as up 3 and left 1 to get that positive 3, negative 1, or negative 3, positive 1. And remember, a negative slope, the line should be going down to the right, whereas a positive slope goes up to the right. And I know I did a little bit of freehand graphing there, but I can say that my graph crosses my two lines intersect at this point right here, because that actually was a point when I walked my slope that was on each line. So no guesswork involved here to determine that this point is a solution. I'm looking at my graph that has an x value of 1, and it has a y value of 1, 2, 3, 4, negative 4. So I'm going to write my solution as 1, negative 4. And I'm assuming that's how you'll want to give your answer. The other way you could write it is, of course, x equals 1, y equals negative 4. Before we go on to another method, this is a good place to kind of stop and consider, will we always have just one solution to a system of equations? In geometry, one of the first postulates we looked at was that if two lines intersect, they will always intersect in, hopefully you're thinking exactly one point. And that's true. So that's leading me to think there will be always one solution. However, you have to ask yourself, will two lines always intersect? And the answer is no, they won't. If we're looking at parallel lines, they will not intersect. So that would be a case where we would have no intersection, and therefore no solution. We could have a system of equations with no solution. We haven't talked about parallel lines. You may remember from algebra that the slopes of parallel lines are the same. So those two numbers, the m values would have to match up. That would be an indication once you solve for y that there would be no solution. Other option, you could actually have two lines that we call coinciding, where one line is exactly on top of the other, and then you would have an infinite number of solutions, as in every point on one line would be on the other line. Okay, that's getting a little bit ahead. Most of the problems that you're doing will have one solution, and graphically we're looking at the point where the two lines cross. Watch the next video if you want to review one of the other